All right, in this video, we're going to go over the concept of a z-score. So a z-score tells you how many standard deviations away from the mean a data value lies. All right, so think of the z-score as being like a distance away from the mean, and its distance is measured by the standard deviations. In order to calculate the z-score, our formula is we take the data value minus the mean, and then we divide that by the standard deviation. All right, and so in different books, sometimes X bar, which is the mean, sometimes they denote X bar as maybe a Y bar or something like that, but just know it's the data value minus the mean over the standard deviation. So a z-score can be either negative or positive or zero. If the data value is the same as the mean, the z-score is going to be zero because the distance is zero. If a z-score is negative, that indicates that our data value is less than or to the left of the mean. A positive z-score indicates that our data value is to the right of the mean or it's above the mean. So let's get into a couple of quick examples here, and hopefully this will clear up the concept of a z-score. So for example, suppose a data set has a mean of 54 and a standard deviation of 5. What is the z-score for a data value of 44? What is the interpretation of this z-score? Okay, so what I want to do here is I just want to copy down the z-score formula, right? So we said it was z-score formula equals our data value, which is x, minus our mean, which is x bar, divided by the standard deviation. Remember, that's the Greek letter sigma. That means standard deviation. So for us, that's going to be a data value of 44 minus our mean, our sample mean is 54. And we divide that by that standard deviation, which they told us was 5. Okay. So this will give us 44 minus 54. That is a negative 10 over 5, which gives us a negative 2. Okay. And really quickly, if you're putting this in the calculator, let me show you what that would look like. Okay, so very important that when you're using the calculator to calculate your z-score, you put your numerator, that data value minus the mean, you put it in parentheses. So I'm going to hit open parentheses. It was 44 minus 54, close parentheses, divide that by 5, and then we get that negative 2. So just wanted to show you how to put that correctly into the calculator. All right, so our z-score is a negative 2. So what does that mean? What's the interpretation of that? For that, let's consider this. So let's say we had a number line, all right? And let's put our mean right smack dab in the middle of that number line. Let's say 54, which is our mean, is right here in the middle. And our data value is 44. 44 is less than 54, so we're going to put it somewhere over here to the left. So what does a z-score of negative 2 tells me? It tells me that if I start at my mean, right, I need to, first of all, the negative indicates I need to go to the left to get to my data value, right? Think of it like this. If I take one instance of my standard deviation, one jump of my standard deviation, remember, we're going in increments of 5 because our standard deviation is 5. One jump to the left of 5 goes from 54 minus 5 to 49. And then if I take another jump of the standard deviation, 49 minus, once again, 5, gives us a difference of 44. So the z-score of negative 2 tells us it takes us 2 standard deviations, 2 jumps of our standard deviations to get from the mean to the data value. That's what a z-score tells you. So what's the interpretation? The interpretation is simply, well, the data value lies 2 standard deviations below, or you can say to the left of the mean. All right, so that's what it means to have a z-score of a negative 2. Let's look at some other examples here. All right, so this one's I know is a little hard to see. All right, so suppose a student scored an 82 on their biology test. Suppose the class average was 85 with a standard deviation of 4. Suppose the same student scored a 90 on their math exam. The class average for the math class was 94, standard deviation of 2. In which class did the student perform better when compared to the rest of the class? Which score can be considered more unusual? So we have two questions kind of packed into this one example here. So first of all, let's talk about how we can compare scores. So when it comes to z-scores, what's really cool about them is that it allows us to compare apples to apples, for example. In this particular example here, we're trying to compare math to biology, and those are just two different sets of data, and we can't really make a one-on-one comparison. But when we make a z-score, we're what we call standardizing the data. That allows us to make these kind of comparisons across data sets. All right, so we're going to have to calculate not one, but two z-scores. So let's talk about the z-score for biology. So I'm going to abbreviate that z-score with the subscript bio. What we do is we take the student's score on their biology test, which was an 82, subtract the mean for biology, which was 85, and we divide that by the standard deviation of 4. Okay, so data value minus the mean divided by the standard deviation. All right, that will give us, if we put that in the calculator, we should get a negative 3/4, which works out to be a negative 0.75. Feel free to pause the video and verify that value. Now let us calculate the z-score for the math class. Okay, so it said the student scored a 90 on their math exam minus the class average for that math test was a 94. Divide that by a standard deviation of 2. So this will give us 90 minus 94 is a negative 4 divided by 2. Here we get a z-score of negative 2. So the question becomes, in which class did the student perform better? Well, for being frank here, he really didn't do great in either one of the classes. How do we know? Because the z-scores are negative, which indicates he scored below the mean. But that's not the question. The question is, which class did he do better, relatively speaking? Well, that is going to be the z-score that's the largest. When you want to talk about better in terms of exam scores, you want the higher score. So the more positive answer, the bigger z-score is going to be your answer. And so keep in mind, these are negatives. So in negative land, the closer you are to 0, the better you are, or the greater you are, right? And so negative 0.75 is closer to 0. Therefore, the student did better in biology. Okay, so the student did better in biology. All right, the next part of that question asked about which score can be considered more unusual. Well, the way that you figure out which data value is more unusual is you look at the z-score. The data value corresponding to the z-score that is the farthest away is the more unusual data value, right? Because remember what we're talking about. Remember, a standard deviation is a typical value away from the norm, right? So the more standard deviations we're away from the mean, the more unusual it is. And the way that we look at that is we just simply look at them and we say, okay, negative 0.75, that's 0.75 standard deviations to the left of the mean. A z-score of negative 2 means we are 2 standard deviations to the left of the mean. Well, which one's farther away? And it doesn't matter which direction you go. It's just which, value is farther away. Well, the math score is 2 standard deviations away, so math is the more unusual score. Okay, once again, that's because its z-score is further away from the mean, which is 0, the z-score of 0, right? Just really quickly, just to piggyback off of this, Let's say we had 2 z-scores. I want to make sure we're clear that the sign doesn't matter when we talk about more unusual. Once again, let's say we're talking about exam scores. Okay. Let's say the z-score of a English class, let's say that was a 0.25. And let's say the z-score for, I don't know, what's another class we could take? Let's say a z-score for a science class is a positive, let's make it a negative 1.5. Okay. So now the question becomes the same thing. In which class did the student do better in? Remember, better means the more positive one. Well, the student did better in English. Okay. Which data value, which data set is more unusual? Well, that's going to be the science. Why is that? Because its z-score of a negative 1.5 is further away from 0 than that other z-score in English of a 0.25. All right, anyways, I hope this helps you out with understanding z-scores, and I'll see you guys in the next video.